two miniature signage LED lamps. One is dead and one is alive, and these were sent to me by Jeremy and Rosie. And Jeremy spends a lot of time in Japan. He spends some of the time in UK working on municipal lighting and some time in Japan working with signage, which is quite an interesting career. And he says, E12 screw cap, I use a lot of these in Japan. They are supposed to be good for any voltage 85 to 285 volts. Keep getting new ones fail very quickly. I have sent you one failed, new one and a good one. Thought you'd like to see what is in these and also maybe pinpoint what is causing the failures. And that does sound quite interesting. And when you take a look at the lamps, they're quite neat. And I kind of recognise them. I kind of recognise the box as well. Inside are, let's zoom in a little bit. Just a little bit. Inside are four 3mm concave lens LEDs. The ones that scatter the light out sideways like Christmas lights. And you can see a bridge rectifier down there. And I'm guessing, I can't see much more of the circuitry, but I'm going to make a wild guess what's in there. And it was kind of familiar because I just so happen to have a little bag of signage style lamps here. And I have one of those lamps already. I've just never got round to opening. So this is a perfect opportunity to open one without actually breaking mine. Excellent. Thank you, Jerry. So let's try these out and see the power consumption. So I'm going to zoom back out here a bit. I'm going to bring up the hoppy meter. Plug it in, at which it will instantly start flickering because, yeah, it's always flickery because of the way this display's multiplexed at quite low speed. Doesn't look flickery to me, but looks flickery to the camera. I'm going to screw in what I think is a working lamp. I've got an adapter in here. And it's not super bright. You'll see a bit of flicker in that because of the way it's running the LED. It's showing a current of about 24 milliamps, which is actually quite high if it's running at the way I think it is, and a power of roughly 1 watt. And the power factor is a horrific 0.159. Okay, that does also give clues as to the circuitry. Let's screw that one in and see what happens. Is it going to go bang or is it going to just be open circuit? My guess is open circuit because if a fault has occurred that would have gone bang, it would have cleared probably. I'll just keep my fingers well out of the way. Nothing. Okay, right. I think it's time to investigate these. But first of all, I'm going to have a wild guess at what's inside, and you're welcome to have a wild guess as well. So I would expect inside one of these lamps to be the absolute... The problem here is the sort of E12 base is tiny. There's really not much room for the circuitry. So I'm expecting the absolute most minimum circuitry of the capacitor. And I have stuck my fingers over the back of these and didn't get a tingle when I took them out. So I'm guessing there's a little discharge resistor across it. The bridge rectifier we could see through the top. Maybe, just maybe, there might be a series resistor if there's enough room in there to limit the current. That'll be somewhere like 10 ohm to 470 ohm. The higher the better in this instance, although arcing, it's not such a good thing. And the output, I can draw the LEDs because there are only 4 LEDs on the output in the series. And each will have a single trip in it. I'll just draw a couple of beams of light coming out. Capacitor for that sort of current, I'm going to guess at 330 nanofarad, just from previous experience. That resistor will be either 470k to 1 megohm. I think it's time to open one of these lamps and investigate. Now, something worth noting, one of them has clear LEDs and one has very, very slightly frosted LEDs. Let's see how close I am with the circuitry. So I shall use my schnips to open this, to peel this back. I wonder if we could get the glass to separate because it's got glue in it. That would be quite interesting. Yeah, you know what? I'm going to try and unglue this first, but I'm going to be using the heat gun for that and I'll have to heat it up. So I'll pause momentarily while I do that. Nope, that was a complete failure. Lamp's still quite hot. I think I'm going to have to peel this open. The glue appears to be really brittle, hard sort of glass cement. So let's go in the complicated way with a pair of snips. Oh, that's still hot. Let's cut the tip off it. Oh, there's a wire going out to the tip. I did see a couple of bunched up wires inside suggesting the circuit board had been pressed down. Oh, let's not snip my fingers. That'd be quite good. Jerry mentioned he spends a couple of days a week when he's in Japan working with a signage company or a specialist neon company, and they do neon tubes in the sort of range of about 2mm to 6mm diameter. That is really specialist. That it requires quite complex processing. Sounds very interesting. It sounds like they don't just do signage as such. They may actually do neon as a sort of spiral lamp type arrangement for situations like, say, beacons and things like that, where you need a very long life lamp that puts out a very strong visible wavelength of light, and red is very good for that. Oh, I should have mentioned possible failure modes with these capacitive droppers are if there's any arcing at all on the lamp holder, it will cause high current pulses, and that will either take out a little series resistor, the one that I guesstimated a value. Oh, there's a capacitor. Oh, there is a resistor in the back, or it will take out the series resistor or the LEDs. There does look like there's a series resistor that is kind of rated. This glue is amazing because it's really tightly onto this glass, and it is glass. Okay, can I get this circuit board out? Give it a quick wiggle and pull. Here is the circuit board. Right. Let's get in close. That is exactly what I was thinking it was, but let's see about the values. And let's see what's gone open circuit. Oh, I'm seeing a pattern on top of this. I don't know if you'll be able to see the pattern on the top. I don't want to zoom in too far because then the resolution will suffer. In fact, I've already zoomed in too far, haven't I? What I'm seeing here then is, here's something to point with. I'll bring in my schematic and I'll point out what's what. Oh, I'm really going to have to zoom right out to get that in, haven't I? Okay. So the supply's coming in and it's going to this capacitor here. Tiny capacitor. It's not hugely tiny. That's the one I think is probably going to be 330 nano. It's got a resistor in series with it. The resistor has no value marked on it. Either that or it's been mounted upside down with the value at the bottom. Then that goes to the bridge rectifier, which is this bit. And then these LEDs will almost certainly be in series. On the other leg, this lead is coming on and it's going to the resistor. And it's this resistor, its job is to limit any sort of high current surges that are going to potentially just pass straight through those LEDs and damage them. And it's got a strange texture on top, as if it may have gone open circuit. Can I repair this lamp? Or is the capacitor the bit that's failed? I would doubt it. I think it might have been, I think something may have arced if there was a dodgy lamp holder, and it may just have blown that resistor. Let's probe it and see what we get on the meter. So this is on resistance. It's going to have a really hugely high value if it's faulty. 327 kilo is huge. Yeah, that resistor has failed. What about this resistor across the discharge resistor here? .2 kilo is completely wrong. That's strange. Or is that maybe a leaky capacitor? Maybe the capacitor's failed and gone short circuit. I'm going to have to desolder them to find that out. Right, okay. Right, one moment please. I'm just going to, well, I've got the soldering iron on. I can do that right now. I'm going to slide this little resistor off. Is going to be the easiest thing. So let's splob some solder on that. This is where I want to go all Louis Rossmann and put a micropole of flux all over it, squirt it on everywhere. I got a bottle of flux recently. I should have loaded it into a syringe and I could have done that. Not because I need to, but just because it's very dramatic. The resistor is off. What is the value marked on the resistor, and what does the resistor read? The resistor is a surface mount resistor. It's absolutely tiny, but it does have a value printed on it, which I'll need to read with a magnifying glass because you guys can probably see better than I can. It's 1004, which is 1 megohm. Let's assume maybe that's working perfectly and get the meter back in and stick it back to resistance, stick it across that and see if it's going to read 1 megohm. It's reading 1 megohm. That does not bode well for this capacitor, which is reading a resistance, which it shouldn't be reading a resistance. That suggests internal failure of the capacitor, and that means that the resistor on the other side has been nuked. And it really, the texture, it's got a black top where the printing should be, but it's kind of blown off. It's sort of burned. It's sort of, you're not going to be able to see this, so I'll draw what I'm seeing here. If this is a resistor, quite a big high power resistor for surface mount resistors, whatever value it was, I'm not going to know because this is the area that's black. It's the layer of carbon, the carbon film, and then the sort of protective coating. But it's kind of blown like that out the middle, and that's all gone very crusty and sort of rocky looking. And it's most likely that's happened as a result of this capacitor here failing. I wonder if the LEDs are still working. I could theoretically test that by putting on a power supply here and finding the output from the bridge rectifier and a resistor. Let's just grab my universal, slightly old and slightly degenerate resistor unit, and I shall put this to here, and we'll just probe about on here with the power supply turned up to about anything above 12 volts. I would say that's going to be fine. That's about 15 or 16 volts. You may hear a whistling noise. That particular power supply does that. So there's a positive connection there. I think these LEDs have possibly all been blown in the process. Yeah, because there's the negative connection there. There's the positive connection to LEDs there. I'm not seeing any light, I'm not getting any current. The LEDs are blown, the resistor's blown. My guess is this little capacitor has not quite survived with its size here. And it's just, basically it's had the peak of 240, they say, well, if Jerry's right and it's got a rating up to about 280 volts, let's go with what our supply here is at the moment. It's about 245 volts. So the peak of the voltage across that is going to be 245 volts times 1.41, because that was AC, and this is the peak of the sine wave, which is about 345 minus the LEDs, which should be about minus 12 volts, equals that capacitor, that little capacitor there is going to have over 330 volts across it. And it looks as though maybe that's just caused it to fail. It may even be there's been arcs and transients that's caused sharp voltage spikes and it's just made it break down. But it looks in this instance as if that capacitor is the culprit in killing these lamps.